Hello, Year 11, and welcome to my second video going through the exam that I set you this week. So, question number 1. Circle the relative frequency that represents 13 successes out of 50 trials. So remember, relative frequency is just another word for experimental probability. So we know 13 out of 50 is the same as 26 out of 100. And 26 out of 100 as a decimal, as a probability, is 0.26. The equation of the straight line is 2y equals 3x plus 5. Circle the gradient of the line. So perhaps a common mistake would be to circle 3, thinking the gradient is 3. This line isn't written in the form y equals mx plus c. So we need to divide everything by 2. And if we divide everything by 2, we would get 3 over 2x, 3 divided by 2. And we'd also get 5 divided by 2, which would be 5 over 2. So the gradient would be 3 over 2, and the intercept would be 5 over 2. So if we're circling the gradient, it is 3 over 2. Question 3. 2x minus 4 bracket 3x plus 5 is expanded and simplified. Circle the term which is part of the answer. So these are expressions that involve x, and the only place that the x part is going to come from is when the outer and the inners combine. So I'm not going to multiply out the whole thing with FOIL, but the outers would be 10x's. The inners would be negative 12x, and 10x take away 12x is negative 2x. Question number 4. When rounded to 3 significant figures, x equals 6.37. Circle the correct error interval. So remember, an error interval is just telling you what the number can be between to 3 significant figures. So if we've got a number that's been rounded to 6.37, there'll be some smaller numbers that round to that. There'll be some larger numbers that round down. And the limiting factors would be, if the number was 6.365, 3 significant figures, it's equivalent to 2 decimal places for this number, that would make it round up to 6.37. And anything that is below 6.375 would round down. Obviously 6.375 exactly would round up, which is why one of these inequalities is the less than value. So the one that we want is the first choice. 6.365 less than or equal to x less than 6.375. Solve the simultaneous equations. Well, the fact that this is question 5 means it's quite an easy simultaneous equation. If you're going to have simultaneous equations on an exam and it's a later question, you're more likely to have a linear and a quadratic. What also makes this question actually incredibly easy, okay, is the fact that they're both plus 2y. So you're probably used to linear equations where you have to multiply by something to make something the same. Well, these are equations where we can do something straight away and not have to manipulate them. It wouldn't surprise me, with this being question 5, this would be a common question on the foundation tier and the higher tier, which is why it's more straightforward. So I'm going to do equation 1, take away equation 2. And if I do that, I have 7x take away 3x, and that's 4x. I have 2y take away 2y, that disappears, it's eliminated. And 36 take away 16 equals 20. So straight away, I get x is 5. I'm going to substitute that into one of the equations. I'm going to substitute it, I believe, into equation 2. It looks a bit easier. 3x's, x is 5, so 15, plus 2y's is 16. And if we solve that, we subtract 15 off both sides. 2y is 1, so y equals a half. So it looks like I've got my answer, but remember, with simultaneous equations, you can do a little check. So let's just check in equation 1. So check in 1, just convince yourself it's right. 7x's, 7 fives, 35, plus 2y's, plus 2 halves is plus 1, and that does indeed equal 36, so you can stop confident that your answer is correct. Question 6, Part A. Tom is tiling a wall. He needs to buy at least 100 tiles. The large packs are 40 tiles at £18. The small pack is 28 tiles at £14. The special offer is a 25% reduction when you buy 3 or more large packs, and it says work out the cheapest cost for Tom to buy the packs of tiles he needs. So there's a couple of different ways you could make at least 100 tiles. For example, you could do 1 small pack and 2 large packs, because that would get you 108 tiles, and that would cost you 14 plus 18 plus 18, and that, I believe, is £50. However, I think the cheapest option is going to be 3 large packs because of this 25% reduction. So if we do 18 times 3, that is £54. But if we want to work out 25% of that, and do remember, of course, you've got your calculator, 25%, half it and half it again, it's £13.50. And when we subtract £13.50 from £54, we get an answer of £40.50. Part B to this question. Tom is also tiling a floor. The floor is a rectangle with length 600 centimeters, width 240 centimeters. Each tile is a square with sides 40. Tom uses this method to work out the number of tiles he needs. So he's divided the length by splitting 600 into 40. So he knows he needs 15 tiles. If we imagine this rectangle, let's pretend this is his floor. He needs 15 tiles wide. He then does the 240 split by 40, and he realised he needed 6 tiles wide, and he's done the total number of tiles needed is 15 add 6. Well, that's his mistake. He needed to do 15 times 6, and 15 times 6 is 90 tiles. So you could write his mistake is he's added rather than multiplied. You could say actually he needs 90 tiles. For 1 mark, either of those arguments would be sufficient. Question 7. Now, I've not got a visualizer with me this evening, so what I'm just going to do is talk through how you would do this question. It says an equilateral triangle has sides length 16 meters. It says using ruler and compass only, construct a scale drawing of the triangle. Use the scale, 1 centimeter represents 2 meters. So how you would start, you would use your ruler and you would draw a line that is 8 centimeters long, because 8 centimeters using the scale would be 16 meters. To create an equilateral triangle, this is like constructing a side triangle. So you would use your compasses, and you'd open up your compasses to this 8 centimeters. You'd put your compass point on there, and you create your arc on this side. You would then do the exact same on this side. Make sure that you don't alter your compasses. You create your arc, and where those 2 arcs intersect, mine obviously doesn't quite perfectly look like an equilateral triangle, you'd get an equilateral triangle. So as long as you've got sides that are all 8 centimeters, you've got these construction lines drawn in, that would be full marks. If you drew it without a pair of compasses, despite it saying it in the question, you would lose marks and potentially only get 1. An examiner would probably have a tracing paper version that they would put over your diagram to see that it's within the accuracy of a couple of millimeters, and they'd also be looking for construction lines. Question number 8. In a choir, there are 35 men and 48 women. The probability that a man chosen at random wears glasses is 2/5. The probability that a woman chosen at random wears glasses is 3/8. Work out the number of people in the choir who wear glasses. So we need to do 2/5 of 35. And remember, you do have a calculator again, but to find a fraction of a number, you divide by the denominator. times by the numerator. So 35 divided by 5 is 7, and times 2 would be 14. So that's 14 men that are wearing glasses. Then 3/8 of 48, very similar. Divide by 8, it's 6, times by 3, 6, 12, 18. So altogether, there are 32 people wearing glasses. It then asks us to work out a person chosen at random from the choir who doesn't wear glasses. So let's just go back and have a look at this question again. We know there are 35 men and 48 women. So altogether, that is 83 people. Let me write that down. There's 83 people altogether. We have just worked out that 32 of them wear glasses. So the rest do not. So we need 83 take away 32. So that means there are altogether 51 people not wearing glasses. So the probability that I pick someone not wearing glasses is 51 out of 83. So just write that as a fraction. You could turn it into a decimal or a percentage, but fractions work best here. Does that fraction cancel down? Doesn't appear so to me, but even if you didn't cancel your fraction down, unless the question says write it in its simplest form, it just does not matter. So 51 out of 83 is perfectly good. Question 9. So I've thrown away all the working out area to fit it on my PowerPoint. So I'm going to do the working out for this question at the side. It says the pie chart shows information about people at a theme park. There are 450 more, in bold, women than men. Work out the number of children. Okay, so we're not told it's 450 women. There's 450 more. So I'm just first of all going to work out this missing angle here, because I'm going to need it later on. I've got women as 65 and men as 35 degrees. So collectively, altogether, that's 100 degrees. So the children is 260 degrees. Now, the next thing that I'm told is that 450 more women than men. Well, let's look at the angles. Okay, women is 65 degrees, men is 35 degrees. So there's 30 degrees more for women. And that must equate to 450 people. So we can work out what 1 degree is. 1 degree equals 450 divided by 30. So 1 degree is 15 degrees is 15 people. So if children is 260 degrees, I need 260 times 15. And 260 times 15 sounds like 2,600 plus 1,300. Of course, you've got your calculator, but it sounds like 3,900 children to me. Okay, question 10. Density is mass divided by volume. The mass is divided by 2, and the volume is multiplied by 4. What happens to the density? Now, questions like this can often be, for some students, quite difficult to see. So what I would generally do in a question like this is I would make up some numbers and see what happens. So, for example, if I made the mass 100 and I made the volume 20, then using these numbers, my density would be 5. Now, I'm going to see what happens if my mass is divided by 2 and my volume is multiplied by 4. So that would make my mass 50 and my volume would be multiplied by 4, which would be 80. And that is now 5/8. Okay, so what has happened to my density? Well, it's gone from 5 to 5 divided by 8. So it's been divided by 8, which is that option there. Question 11 says, work out cube root of 512 to the reciprocal of 0.4. Give your answer in the form n to 1. So this is a ratio question, writing something in the form n to 1, but it's also testing your your knowledge and your vocabulary of things like cube roots and reciprocals. So you can use your cube root button for 512, but I think I know the cube root of 512. Okay, sounds like 8 to me. The reciprocal of 0.4 means 1 divided by 0.4. And that one is 2.5. So I'm now writing that ratio 8 to 2.5 in the form n to 1. So I need to make that number become 1, and I will do that by dividing by 2.5. So what do we need to do? Well, we need to divide 8 by 2.5. So, yeah, it'd be great if I grabbed my calculator and just did this, but I know that 8 divided by 2.5 is the same as 16 divided by 5, and that's the same as 32 divided by 10, just using some equivalent fractions. So without my calculator, I know it's 3.2 to 1. Question 12. Again, I've cut off the answer area for this, so I've got room to do the question, so I'll do the working out at the side. It says the graph shows how much Molly is paid for working up to 40 hours. So it says she receives a basic rate of pay for the first 35 hours worked, represented by the gradient of this line, and then a higher rate of pay for the next 5 hours. And again, that's represented by the gradient of this line. It says work out the difference between the higher rate of pay and the basic rate of pay. Give your answer in pounds per hour. Okay, now there's some sensible numbers that you could pick off this graph to work out these rates of pay. So I'm going to use this one here, because what I can see is if she works on her basic rate for 10 hours, she gets paid £80. So we can immediately see that if it's £80 in 10 hours, it's £8 per hour. Now, it's slightly trickier on this section because we need to see what's going on between here and here. So this represents working for an extra 5 hours, and you can see why it is the gradient, but what I need to see is how much extra she gets for those 5 hours. Now this number here is 280, and this number here is 350. So for 5 hours work, she is getting £70. So the higher rate is 70 in 5 hours, and 70 divided by 5 is £14 per hour. So the difference between the higher and the lower is £6 per hour. Question 13. Naga states a hypothesis. Most people read more than 100 books a year. She asks a sample of 5 people in a book club how many books they have read last month. The table shows the results. Show how Naga could use the data to support her hypothesis. Okay, now the fact is that we have Paul, who reads 8 books in a month. So assuming that he carries on with that, we've got 8 times 12. Well, he is 96 books. Okay, which means all of the other 4 people, when you times their numbers by 12, they would be reading 100 books or over 100 books a year. Okay, so I would say 4 out of 5 would be over 100. But there's a few little caveats to that, and that's going to be where part B comes in. It says, give 2 reasons why this sample should not be used to support her hypothesis. Well, reason number 1, she has asked 5 people, so the sample size is way too small. And the other caveat was what I said a moment ago. We are making a huge assumption that people read the same amount of books every single month. And I know for a fact that isn't necessarily true. Maybe in the summer holidays, you might read more books than perhaps what you would do during term time. So give 2 reasons. The second reason, we have assumed the people read the same each month. Okay, so it would be better to not use a sample that's monthly, but to use a sample that was actually yearly. So use a yearly sample. Question 14. A graph has equation y equals x cubed plus a, where a is an integer. The graph passes through the point 329. Draw the graph. Now, we are not going to be able to draw the graph unless we know what this function is. But we are fortunate to know it goes through 329. Well, let's see what happens when x is 3. If we cube 3, we get 27. Okay? But we know that y needs to be 29. But we've got this plus a part. Okay? So that plus a part, the extra bit, is helping us work out how we can get to 29. So we need to add 2. A is 2. So we've now got the function y equals x cubed plus 2. And now we're just going to plot the points on the graph. We know that it's 329. So there's 329. If we do 2 cubed plus 2, 2 cubed is 8, plus 2 is 10. So we've got 210. Let's do 1 cubed plus 2. 1 cubed plus 2 is 3. So we know it goes through 1, 3. We know it goes through 0, 2. And if I keep on carrying on with this pattern, negative 1 cubed is negative 1, add 2 is positive 1. Negative 2 cubed is 8. Sorry, negative 2 cubed is negative 8, plus 2 is negative 6. So minus 2 minus 6. And then negative 3 cubed is negative 27, but add 2 is negative 25. So in essence, we're working out the points, but without drawing a table of values. You could draw a table of values if you found it useful. So we get this very typical cubic shape. It's one where there's a point of inflection. You do your best job to draw in your curve. You will do a better job than me because it's very difficult doing this on a tablet. Okay, and that is what your graph would look like. Question 15. All to do with income tax, and this is quite a challenging question to get your head round. It's even more challenging to read. When you earn money, you pay income tax. The amount that you pay depends on how much you earn that year. So you pay 0% on the first £12,500 that you earn. So that's £12,500 tax-free. It's then 20% on the next 37,500 you earn. And then 40% on the next 112,500 you earn. And it says 1 year, Kim paid £9,260 income tax. And it says, work out how much she earned that year. So that money, the £9,260, is coming from these 3 sections. Okay? So if she earned £12,500, she pays no tax whatsoever. Okay, it then says you pay 20% on the next £37,500. So I'm going to make the assumption that she must have earned more than £37,500 to pay this much income tax. So let's see how much tax you would pay if you earn this extra £37,500 on top of the 12,500. So let's do 20% of 37,500. Okay, just make it clear, collectively that is £50,000. So what that's saying is if you earn £50,000, the first £12,500 you pay no tax, and it's only the next £37,500 that you'll pay the 20% of. 20% of £37,500 is 7,500. Okay, so if you earn £50,000, you'd then be paying 7,500 in tax. But she's paying more than that, so she's got some sort of percentage of this next tax bracket. So let's see if you're with me so far. If you'd earned £50,000, the rest of the tax must be coming from this extra money that she's earning. So let's see what the difference is. 9,260 take away 7,500. Okay, and if I do that, 9,260 take away 7,500 is 1,760. So whatever extra she's earning, that must be 40% of it. Okay, so what I'm going to say is that number must represent the 40%. So I really need to find out what 100% of that number is, because that will help me understand how much extra she earns above the 50,000. Okay? This question really makes more sense if you're earning money. So this is quite difficult for you as students. So if I know what 40% is, I can divide it by 4 to work out 10%. And if I times it by times it by 10, I get that is an extra £4,400. So what that tells me is she's getting £50,000 for her salary plus 4,400. And the reason why I know that is because the 20% of this is the 7,500, and 40% of this number is getting the extra £1,760. So altogether, her salary must be £54,400. Might be a good idea if at some point we do some more questions a little bit like that. Question 16. A building company employs 2 labourers, 14 joiners, 9 electricians, 8 plumbers. And for a job, the company needs 1 of each type of worker. In how many ways can the company choose the 4 workers? So this is kind of a probability question in terms of combinations. So we know there's 2 labourers. I'll call them L1 and L2. There's 14 joiners. I'm not going to write them all out. There's 9 electricians. And there's 8 plumbers. And it's saying how many different combinations of these can you have? Well, this is just using some multiplication, because you've got 2 choices there, you've got 14 choices there, 9 choices there, and 8 choices there. So altogether, there must be that many different combinations. So 2 times 14 times 9 times 8 is 2,016 different ways they could utilise their workforce. In part B of the question, it says 1 labourer and 2 plumbers are on holiday. In how many ways can the company now choose the 4 workers? Okay, so what that is doing is reducing some of the numbers. So instead of it being 2 times 14 times 9 times 8, we are 1 labourer less. We are 2 plumbers less. So that is 1 choice of the labourer. Still 14 choices for the joiner. We are now still at 9 choices for the electrician, but the plumbers are down to 6. So we just have to do 1 times 14 times 9 times 6. And now it is 756 different ways. Okay, let's take a look at question 17. Now, question 17 is about function notation, and we're due to do some work on functions a little bit later on this year. Though you might have met some of the ideas of functions and function notation in year 8. So this will make sense to you even if you haven't seen it before. It says f of x is 3x squared, take 4x plus 8 for all values of x, and Jenny says that f of 10 must equal 2 lots of f of 5 because 10 is 2 times 5. Is Jenny correct? Now f of 10 just means the value of the function if you substitute in x equals 10. So let's see what that is worth. F of 10 is just 3 lots of 10 squared, take away 4 lots of 10 plus 8. Of course, we're going to have to use BIDMAS, so let's just be a little bit careful. It's 10 squared times 3, which is 300. Take away 4 tens, which is take away 40, plus 8, and that equals 268. So, is that the same as 2 lots of f of 5? Well, let's work out f of 5. F of 5 is this time 3 times 5 squared. Take away 4 times 5 plus 8. And again, using BIDMAS, 5 squared, 25, times 3, 75. Take away 4 times 5, take away 20, and plus 8. And that equals 55 plus 8 is 63. So, is 2 of these the same as this? Well, let's see. 2 times 63 is 126. But that does not equal, really good sign to use, 268. So is Jenny correct? Make sure you write it. The answer is no. Question 18, it says work out the 2 roots of this quadratic equation. It has already been factorized for you. It says circle both roots. So if you only circled one answer, you would get this wrong. Okay? So this is just doing the either or business. A lot of you would be able to do this in your head. So if I've got the first bracket equals 0 or the second bracket equals 0. If this one equals 0, we get an answer of -1/7. If this one equals 0, if you need to write this out, write it out. We'd have to add 3 to both sides, then divide by 2. It would be 3/2. So it's this one here, and it is this one here. Question 19, again, I've reduced this diagram so we can see it all on one slide. It says here is a cuboid, 8, 13 for those 2 lengths. Work out the size of angle DBH. DBH draws out that angle there. So this is a 3D trigonometry question, but that angle there would be a right angle. Okay, so the 8 would be opposite my angle. The 13 would be my adjacent. So this is a tan question. Tan theta is 8/13. Theta is tan to the -1 of 8 divided by 13. Stick that into your calculator. Make sure your calculator's in degrees. Mine is not. Let's fix it. Tan to the -1 of 8 divided by 13. And we get the answer 31.6 degrees. That's 1 decimal place. Okay, B says, use your answer to part A to work out the size of angle ECG. Now that kind of implies to me that this shouldn't take a great deal of time. It's also only worth 1 mark. And ECG, E, C, G, is that angle there. Now, if we think of the symmetry of this situation, this triangle, although it might not look it, is identical to this triangle, with this angle at the top being the same as theta. So all we need to do is work out 180 degrees minus 90 minus 31.6, just using angles in a triangle. So the angle that we're trying to work out must be 58.4. Okay? So the fact that it was only worth 1 mark was a dead giveaway that I wasn't going to have to do a great deal of work to get to that answer. Okay, looking at question 20, I'm afraid again this is a topic that we have not met yet, but it is only worth 1 mark, and perhaps using a little bit of common sense you can work out the answer to this one. It says P is negative 1, 1, and it is a point on the circle, centre 0, radius r. Work out the value of the radius. So in other words, how long is this line segment? This actually kind of can turn into a Pythagoras question, because if the coordinate of P is minus 1, 1, then this point would be minus 1, which makes the length of this side 1. If this is y coordinate 1, it would make the length of this side 1. If we use Pythagoras' theorem, this side, call it x, x squared is 1 squared plus 1 squared. X squared is 2. So the length is the square root of 2. Question 21. Okay, looks already interesting. Looks very, very similar to maybe a topic we've done recently. Again, I've left out a lot of the space, so I'll do the working out at the side. Juice is sold in small and large bottles, the volume of the large bottle being 1,125 millilitres. And we have got a volume ratio. The volume of the small bottle to the volume of the large bottle is 2 to 5. It then says a cafe has small glasses and large glasses, the ratio being 4 to 7. It then says a small bottle fills 6 small glasses with no juice left over. How many large glasses can be filled by a large bottle? You must show working out. So initially I thought this was going to be a similarity question, but it isn't actually. It ends up being a ratio question. So the first thing that we're going to do is work out the volume of the small bottle, because we know the volume of the big bottle, and we have the ratio here. So the 1,125 millilitres corresponds to 5 parts. So let's work out 1 part by dividing that by 5. So 1,125 divided by 5 is 225 mil. So that is 1 part, but we know the small bottle is 2 parts. So doubling that, the small bottle is 450 mil. Brilliant. Okay, we now know that the small bottle fills 6 small glasses with no juice left over. So we can use the 450 and the 6 small glasses, notice I'm not using this ratio yet, to work out the volume of a small glass. So 450 divided by 6 will give us the volume of the small glass. 450 divided by 6 is 75 mil. So a small glass is 75 mil. And that is 4 parts. Using this second ratio. Okay? Which means, dividing that by 4, that 1 part of the glass ratio, 1 part divided by 4 is 18.75 mil. So that means that the big glass, which is 7 parts, must be 18.75 times 7. And that is 131.25 mil. So that is the volume of the big glass. And it now says how many large glasses can be filled by the large bottle. You must show working. Well, I've got loads of working. So we just need to see how many of these can go into this. So it's just now 1,125 divided by 131.25. Will we get a exact answer? My gut says no. No, we don't. We get an answer of 8.57. So how many large glasses can be filled? Interpret your answer. Sir can't spell. It is 8 glasses. So we have to round that number down. Question 22. The only solution to this quadratic equation is x equals 5. Work out the value of b and c. So this is an example of a quadratic equation that only has one solution. Or in other words, it has the same solution, but twice. What I mean by that is the brackets are identical, which leads you to what we called a repeated root. Now, how would you get x equals 5 is the answer? Well, it would be if x minus 5 equaled 0. Which means the two brackets that we need are x minus 5 and x minus 5 repeated. That would give us the answer x equals 5. Now, to get my b and c, I'm just going to expand this using FOIL. And I will get x squared minus 10x plus 25 equals 0. I realise I've missed out one step there, but I know you are good at doing quadratic expansion. So the value of b is negative 10. The value of c is 25. Moving on to question 23. As I gloss through the test paper, this is the question that I thought, if I'm going to go wrong on one question, it would be this one. Okay, it says, x to y is a quarter to 2/3. Well, that looks horrid. What is x as a fraction of y? Okay, so in other words, what is this number as a fraction of this number? And even saying that out loud still makes me scratch my head as to what it's asking. So the first thing that I'm going to do is I'm going to rewrite this ratio. Why? Because I just don't like the fractions with different denominators. So I'm going to think of a common denominator of 4 and 3 and just see if this starts making more sense in my mind. So common denominator of 4 and 3 is 12. And 1/4 is 3/12. And 2/3 times in by 4 is 8/12. Now I'm starting to see why some of these numbers involve 3 and 8. Now it says, what fraction of what is x as a fraction of y? And I'm still not really sure what to do. So I'm going to come up with a really easier question instead. And I'm going to imagine if I had the ratio x to y, is 2:4. Why am I doing that? Well, because I can answer this question really easily. What is x, the 2, as a fraction of y? Well, 2 is half of that number. And how have I done it? Well, how can I get it from these numbers? It's this one divided by this one. So it was 2 divided by 4, which is a half. And that idea now tells me what I want to do with these to make sure that I do my calculation the right way round. I need to do 3/12 divided by 8/12. And again, you could do this on your calculator, but I know that to divide by a fraction, I multiply by the reciprocal. Those would cancel, so the answer is 3/8. So whenever you get stuck, a really good strategy is change the question, but make the numbers really easy for something that you can then think through in your head. Question 24 is a transformation question. It says, describe the single transformation that takes A to B. It's worth 3 marks. Well, we can see from A to B, the shape is getting smaller. So it is an enlargement, even though it's getting smaller. We then need to talk about the scale factor. Okay, now the scale factor, it's half the size, but the shape's also rotated as well. So that's giving me a clue that it's actually a negative scale factor. So the scale factor is -1/2 from A to B. And if you want to find the centre, which is the final point for the mark, we draw in the rays. Well, that corner corresponds to that corner. That definitely looks straight there. And I think it's going to go through that point there. So I'm going to cheat and do it in 3 sections. Okay, that's better. So there is my centre at 1, -1. The area under a speed time graph represents distance travelled. So all I need to do is work out the areas of these 3 shapes. I've got a triangle, I've got a rectangle, and I've got, slightly awkwardly, a trapezium. I've also got another slight complication, that the speed is in kilometers per hour and the time is in minutes. So I really need to convert this into some sort of scale in hours. Now I know from 45 to 60 minutes, that's 1/4 of an hour. So that distance there, I'm going to call a quarter. I know that this distance here, between 5 and 45, is 40 minutes. And 40 minutes as a fraction of an hour, 40 out of 60, is 2/3. And 5 minutes is a 1/12 of an hour, 5 over 60. So I'm now going to use these numbers and the height, the speed, to work out the areas of each of these shapes. So for the triangle, it's 102 times a 12th divided by 2. So the area of this triangle comes out as 4 1/4. So that distance travelled is 4 1/4 kilometres. Section 2, which might be a section that you had a bit of success on because it's a straight section of the graph, and you might have said if you're going at a speed of 102 for 40 minutes, you might be able to work out that distance. So you might have this answer in as part of your working out. So it's 102 times 2/3. And that would be 68 kilometres. And then section 3 is the awkward one because it's a trapezium. So remember, the formula for the area of a trapezium is half of your 2 parallel sides added together. So that's 102 plus 96. And then I'm going to be timesing it by a quarter. So to work this out, I'm going to do 102 plus 96. And to get the half, I'm going to divide it by 2. And then I'm using my fraction button, so I'm timesing it by a quarter. And that one comes out as 24 3/4. So if you add these 3 bits together, we can see how far has been travelled so far. And that comes out as 97 of the 130 kilometres. So when it says how far is left to travel, it is 33 kilometres. Question 26 is to do with trigonometry. Here is a triangular sail. Vicky needs to buy waterproofing liquid for the sail. She will put 3 coats of liquid on each side. I can already see where some students would go wrong. A litre of liquid covers 8.5 square metres of the sail. How many 1 litre bottles does Vicky need? Okay, so we're actually going to be using the formula for the area of a triangle that is half AB sine C. So that is a trigonometric formula for working out the area of a triangle, and it works really nicely when you have a side angle side, because that is your C. I'll call that A, that B, but these are your little a and your little b. So I can work out the area of this sail quite easily by doing a half times 3.8 times 9.7 times sine of 73. And that will be exactly what I type into my calculator. And when you do that, and your calculator is in degrees, you should get an answer of 17.62. I'm going to write down the whole decimal at this stage, and you'll understand why, because I'm still doing more work. Okay, now, the thing is, she says she's going to put 3 coats of the liquid on each side of the sail. So it's not just that area we need to double it for both sides, and she's going to do it 3 times. So I actually need to take this number, times it by 2 for the 2 sides, and times it by 3 for the 3 coats. In essence, she times in the number by 6. And at this point, this is where I'm going to round it. So the area of paint, or waterproofing, or whatever what you want to call it, I'm going to call it paint, even though it's not paint, comes out at 105.7. And I'll round it there to 1 decimal place. That is meters squared. You then have the bit of information that the 1 litre can cover 8.5. So we need to see how many 8.5s go into this. So we divide it by 8.5 and we get 12.4 bottles. But obviously you can't buy 0.4 of a bottle, so we have to round that up to 13 bottles. For part B, we have got more trigonometry. It says another sail is joined to the first sail as shown. X is an acute angle. Work out the size of angle X. So this is worth 5 marks, and it's going to be 2 lots of non-right angled trigonometry. So what I'm seeing immediately here is I have a side angle side triangle, so I can use the cosine rule to work out this side, this vertical side here, which I'll call y. And then I also know when I've worked out y, I will have some opposite pairs in this other triangle that I will be able to use the sine rule for. So let me set this up with my initial a, b, and c. So remember, for the cosine rule, we have got a squared equals b squared plus c squared minus 2bc cosine of a. So I'm going to call this one a, this one b, this one c. So what I called little y is my little a. What I called 9.7 is my little c, and this one is b. So again, it's just a case of putting some numbers in. I need to do b squared, 3.8 squared, plus 9.7 squared, minus 2 times 9.7 times 3.8 cosine of 73. I'm going to work some of these things out. I'm going to do the 3.8 squared plus the 9.7 squared. So those two things add together to be 108.53. Then I'm going to work out all of this, the 2 times 9.7 times 3.8. And that comes out at 73.72 cosine of 73. Now, when some students haven't done the cosine rule for a while, they might subtract these two numbers, but it is only this number that is being multiplied by cos 73. So don't think there's a bracket here. There isn't. So type all of that into your calculator. 108.53 take away 73.72 cosine 73. And that comes out as 86.976 and some other bits after it. Now that is a squared. I need to do the square root of that to work out a. So I've got a as 9.3 26111 and at this stage I'm not going to do any rounding. Okay, I'm going to use a different colour to now look at this triangle here. Since this one's called B already, I'm still going to call it B. Since this one is called C already, I'm going to keep with it called C, but I'm now going to call this one A instead. So I'm now looking at my triangles with the purple edges. This would be A, this would be little b, this would be little c. Now remember the sine rule, and the one that I want for working out an angle, will say sine A over little a equals the pair that I want, the pair that I've got, sine B over little b. And I'm going to substitute in what I currently know. So sine of x, because I'm trying to work out angle A, divided by this lovely 9.32. I'll just write it like that for the time being, but when I put it into my calculator, I will type it in full. Equals sine of 42 divided by 8. Start rearranging this by taking the divide by 9.32 up to be a multiply. So 9.32 ... times sine 42 divided by 8. Okay. Now, that is going to give us what sine of x is. And you could type all of that into your calculator first and then do sine to the minus 1 of your answer. But we, in essence, need to do sine to the minus 1 of all of that. Okay? So probably the easiest way is typing that into your calculator, then doing sine to the minus 1 of the answer. I can't remember whether at the start of year 10 you liked trying to type it all in one go. So I'm going to type it in first, 9.32. I'm going to use the full decimal, 6111619. Sine 42 divided by 8. And then sine to the minus 1 of that gets me an answer of 51.3 to 1 decimal place. If you want my full calculator display, it's 51.265000161, but 51.3 to 1 decimal place. Question 27. Here is a quadrilateral PQRS. P to S is A, S to R is B, R to Q is C. It is not drawn accurately. X is a point on PS that splits it in the ratio 1 to 2, and Y is a point on RQ that splits that line segment in the ratio 2 to 1. Is XY parallel to PQ? Show working out to support your answer. Okay, so let's talk about some of the basics first. In order for two vectors to be parallel, one's got to be a multiple of the other. So all I'm going to do is work out a vector that represents xy, a vector that represents PQ, and see if one is a multiple of the other. You might argue from a quick glance, it looks like they're parallel, but remember the diagram's not drawn accurately. So, if I'm first of all going to do the easy vector, let's swap back to red. The easy vector, P to Q, going around my defined routes is just A plus B plus C. Now, thinking about X to Y, we can use some of our ratios. So we know that X to S is 2/3 of this line segment. Well, if the whole thing is A, this is 2/3 of A. S to R is still B. And R to Y is 2/3 of C. So X to Y is 2/3 of A plus B plus 2/3 of C. Now, in order for these to be parallel, one needs to be a multiple of the other. And that isn't the case because we would need the B to be 2/3 as well. So, I'm going to say XY is not a multiple of PQ. You could even go on to say it needs to be 2/3 B. So is XY parallel to PQ? It's not a multiple, so not parallel. Question 28. There was a function notation question earlier. This is another function. It's actually a composite function, and this will be some of the new maths we also talk about. You might be aware that f to the -1 is going to be an inverse function. So let me explain how this works. It says, show that the inverse function of f when you substitute in 55 is the same as something called a composite function of fg when you substitute in 4. Okay, the fact that it says show that they are the same means when we have finished this, we will at least know we've got the right answer because we will get two identical values. So I'm going to start with the easier one first, which is f of g of 4. Now what that means is you work out what g of 4 is. In other words, you substitute 4 into this expression, and 4 squared is 16. You then take the answer to g of 4 and substitute that into f. That's what f g of 4 means. So I now need to do f of 16. And that is 2 times 16, 32, take away 3, which is 29. So I now know that fg of 4 is 29. Now, this, and definitely if I taught you in year 8, you have seen this, is the inverse function of f of x. And I'm just going to use a little flow diagram to explain what's happening in f of x. So f of x takes the function, takes the value of x, times it by 2, and then subtracts 3. So an inverse function of that would do the opposite, but it would do it in the opposite order. So the inverse of taking away 3 is adding 3, and the inverse of timesing by 2 is dividing by 2. So my inverse function, f to the -1 of x, takes the value of x, it adds 3, and then it divides by 2. And we need to see what happens when we do that for 55. So we have 55 plus 3 divided by 2. 55 plus 3 is 58. Divided by 2 is 29. And that would be enough for full marks because we have shown that they are both 29, and I'll just make it super crystal clear. 29 equals 29. So that is the solution to that question. If you have anything that you want to ask about this paper, please feel free to drop a comment in Teams or speak to me